Hi everyone. Today we will discuss about standardization of a base. First of all, let us introduce ourselves. My name is Ibnah Wardanaila, NPM 2017-011048.
My name is Anastasia Fiorelia, NPM 2017-011062.
My name is Tiara Ramadhani, NPM 2017011027.
My name is Diansa Fitriani, NPM 2017-011086.
My name is Najla Salma Zahra, NPM 20570110115.
My name is Muhammad Dwi Febrianto, NPM 20570111006. Standardization is a process when the concentration of a secondary standard solution is determined precisely by titration with a primary standard solution.
The purpose of standardization of base is to determining the exact concentration molarity of a solution. Titration is one type of analytical procedure often used in standardization. In a titration, an exact volume of one substance is reacted with a known amount of another substance.
Materials in it are hydrochloric acid and AOH. Phenolphthalein is the indicator, 100 ml graduate cylinder, 500 ml volumetric flask with stopper, 1000 ml volumetric flask with stopper, 125 ml Erlenmeyer flask, burette 25 ml or 50 ml, reading paper and white paper.
Put the burette in the clamp, making sure it is positioned vertical and there is enough room to position your flask under the tip. Check to see the stopcock in the closed position. Insert the funnel into the top of the burette and fill with natrium hydroxide as the titration almost to the top. Filling actually to the zero mark is not necessary, but you do need sufficient titration to complete the reaction.
Check the column of air bubbles and gently tap to free them from the set walls. Remove the funnel. Place the Erlenmeyer flask under the tip and open the stopcock. Allow a few milliliters of titrant to flow through, releasing any trapped air. Record your static volume. It is important to accurately read the volume on the burette. First, note that the liquid forms a concave meniscus because the water pulls itself up the set walls of the glass.
You should read the volume from the bottom of the meniscus at eye level. Secondly, it is important to read your volume to the correct number of significant figures. This barrel indicates volume to the next 0.1 milliliter. With any graduated glass will record the volume to one additional decimal place beyond small graduation. In this case, record volume to next hundred of a milliliters, estimating the final place.
Use the volumetric detail to transfer the hydrochloric acid as the analyte to the flask. Add a few drops of phenolphthalein as the indicators to the flask and swirl. Place the flask under the tip of burette. Record this volume. Placing a piece of white paper under the Erlenmeyer flask may make it easier to detect the color change. Operating the burette requires two hands. One hand turns the stopcock while the other hand swirls the flask.
Practice turning the stopcock a few times to familiarize yourself with how quickly the flow starts and stops. It is common laboratory practice that the first titration is an estimate. Open up the stopcock and allow the titrant to enter the flask. Quickly, continuously swirl the flask. As the volume of titrant in the flask increases, the color of the indicator appears and disappears as you swirl. When the analyte becomes a color solution, Close the stopcock. Record the final volume of the burette. Subtract the initial volume from this final volume to get the estimate volume of titrant needed for this titration. Knowing the volume, there is a little pass endpoint. Subtract 5 ml from that number to get the amount of titrant that can be safely added before a slower addition is required. As the estimate titration shows a dark color solution, indicates an excess of titrant has been added. The desired endpoint is a pale, faintly colored analyte to reduce the risk of passing the endpoint. Slow down the addition of titrant when flashes of color begin to appear in the analyte. Adjust the stopcock to slow the flow, the titrant to a drop-wise rate. Continue to swirl the flash with one hand and keep the other hand ready to close the stopcock. When you notice the indicator taking longer to fade, close the stopcock. Record the final volume on the burette. If the analyte remains faintly colored, then you have reached the endpoint. If the analyte is still colorless, then repeat these steps. Add a drop, rinse, swirl, and record until a faint color persists. Typically, titrations are performed in triplicate. Use average volume of titrant required for calculation.
Question number 1. A total of 40 ml of 0.25 mol sulfuric acid solution was titrated with a monovalent base, and it turned out that 57 ml of this base was needed. What is the impurity of the base used? The answer: the naturalization reaction occurs between sulfuric acid H2SO4, a strong acid with 2 valence, and a base with 1 valence. Ma multiply Va multiply valence A equals Mb multiply Vb multiply valence B. M H2SO4 multiply V H2SO4 multiply valence H2SO4 equals Mb multiply Vb multiply valence B. 0.25 mol multiply 40 ml multiply 2 equals Mb multiply 47 ml multiply 1. Mb equals 0.25 multiply 40 multiply 2 divide by 47 multiply 1. Mb equals 0.35 mol.